we're going to be looking at total internal reflection. We need to consider light travelling from a medium of high density to a medium of low density. So that is where the refractive index of the incident medium is greater than the refractive index of the refracted medium. Also, the angle of incidence is less than the critical angle. So most of the light will be refracted, but some of the light will be internally reflected. The refracted ray will be bent away from the normal, and Snell's law will be obeyed, and the internally reflected ray will have an angle of reflection that equals the angle of incidence. Now, if we consider if we was to increase the angle of incidence, then the refracted ray will move increasingly towards the boundary. So when the angle of incidence equals the critical angle, then the refracted ray will be 90 degrees from the normal, that is along the boundary, and you'll have the internally reflected ray. So from Snell's law, the angle of incidence equals the critical angle, and the angle of refraction equals 90 degrees. So sine of the critical angle equals the refractive index of the refracted medium divided by the refractive index of the incident medium. So we can see that the critical angle depends upon the refractive indices of the media. If we consider the case when light is travelling from a high density medium which has a refractive index of n to air, then nr will equal the refractive index of air, which is approximately 1. So sine c will equal 1 divided by the refractive index of the medium. When the angle of incidence is greater than the critical angle, then no more refraction occurs. We only have total internal reflection. That is, all the light is internally reflected. And total internal reflection occurs in optical fibres, where there will be continuous total internal reflections at the sides of the fibre. If we consider the case of light travelling from a low density medium to a high density medium, then the light will be refracted towards the normal, that is away from the boundary. And here is the internally reflected ray. And if we was to increase the angle of incidence, then the refracted ray will move towards the normal, that is away from the boundary. And so total internal reflection cannot occur. So there are two conditions for total internal reflection. One is that light has to travel from a high density medium to a low density medium, or a medium of high refractive index to a medium of lower refractive index. And the angle of incidence has to be greater than the critical angle.